welcome to Easy BTech, your guide for BTech and beyond. In this video, we'll learn about the traveling wave. What is meant by traveling wave? How we can analyze these traveling waves in transit. What is meant by this traveling wave? The traveling wave is nothing but the lightning, the lightning discharge, the lightning discharge, or sudden switching in or out, sudden switching in or out results in the impression of an electric energy suddenly in a transmission line. Transmission line is called traveling wave. For example, I am taking, assume that it is a transmission line, a sudden discharge surge due to the lightning effect. The surge is induced in the transmission line. It is flowing through the transmission line is called traveling wave. How the traveling wave is there in the overhead transmission systems or underground cables? Due to the lightning discharge is the one reason. Another one is sudden switching in or out. Okay, due to that, suppose assume that suppose this is the transmission system. If we are closing this one, suddenly the voltage waveform will appear in the transmission line. If we out this one, suddenly disappear this one. This sudden phenomena will create the traveling waves in overhead transmission systems. What is the speed of this traveling wave? Therefore, this speed of the wave is equals to speed of light. Then what is the speed of light? Is nothing but 3 into 10 power 8 meters per second. This same speed of light is equals to speed of the wave in transmission lines. Okay. Now, how we will analyze the traveling wave? I am taking in y-axis. In y-axis, voltage in kV. I am taking in x-axis, time in microseconds. So this is the maximum value. This is 50% of the wave. Here it is 100% of the wave. It is 50% of the wave. Here, this part is called wave front, and this part is called wave tail. Okay. The timings are represented with T1. T1 is the time taken the waveform to reach from 0 to 100%. 0 to 100%. Okay, this is the T1. The waveform takes 0 to 100%. Our maximum value is called T1. I am representing the another timing. It is T2. T2 is the time taken from 0 to the waveform from 0 to after peak 50%. Okay, 0 to 50% after peak. 0 to 50% after peak, after reaching the peak. Okay. Now, here once again I am repeating the timings because this timing, depending upon this timing only, we will represent the waveform. T1 is 0 to 100%, T2 is 0 to 50% after reaching the peak. Okay. Now, how, suppose for example, this T1 equals to 1 microsecond, if T1 equals to 1 microsecond and T2 equals to 50 microsecond, how we will represent this waveform? We will represent this waveform 1 by 50. 1 by 50, it indicates that T1, 1 indicates that T1 and 50 indicates that T2. Okay, therefore this waveform is represent with 1 by 50. Okay, now the evaluation of impulse wave. Evaluation of impulse. This waveform can be evaluated V equals to V naught into e power minus alpha t minus e power minus beta t. What is the alpha and beta here? Here alpha and beta are control the wavefront and wavetail. Wavefront and wavetail. Okay, alpha. Suppose for example, if you take 1.2 by 50 microsecond impulse wave, the value of alpha equals to minus 0.01436 and beta equals to minus 2.467 for this waveform. Okay. Alpha and beta, by changing the alpha and beta, you can control wavefront and wavetail. We can evaluate the expression for voltage waveform V equals to, this is the initial voltage, into e power minus alpha t minus e power minus beta t. Okay, this is the way we will calculate impulse wave, and in this video we'll learn about what is meant by traveling wave, how it will occur in the transmission lines, how we will represent the traveling wave, what is mean by wavefront, what is mean by wavetail, how we will represent, how we will evaluate, what is mean by alpha, what is mean by beta, what is their importance in traveling waves. Okay, thank you very much for watching.